Behavior trees are one of the preferred ways for controlling the behavior of non-player characters, even for modern games, due to how easily they can be created and extended. At his core, AI Designer is a classic behavior tree implementation for Unity. On top of that, AI Designer also integrates with Unity Visual Scripting, which means entire node logics can be created without writing a single line of code, which is great if you are an artist and want to explore all the possibilities of AI in Unity. Also, if you are a programmer like me, sometimes creating a simple visual scripting node for a custom node logic that won't be shared with several behavior trees and making changes on the fly comes handy from time to time. For example, we can make this zombie attack this unit without creating a single line of code. We start by creating a sequence node which executes his child task from left to right. Next, add a visual scripting node. Open the visual scripting graph, and in order to get the position for the UnityChan unit, we need to use the game object find method. Set the zombie unit destination using the NavMesh agent component. Connect the trigger nodes so the graph knows where the execution starts and ends. Next, we need to wait until the zombie unit reaches his target position. We can do this by using a pre-made node. Now for the attack animation loop. Use another visual scripting graph to set the attack animation trigger. And let's use a wait node to create a cooldown. These nodes also needs to be encapsulated in a sequence node, so the task can execute in order from left to right. We can also change the node names so it is easier to understand what they are doing. Now it is time to test. As you can see, the zombie unit moves to the desired position and starts the attack animation. AI Designer also uses ports, which help us to create a clear separation from the node logic and the code getting the values, making your nodes modular and reusable. To show this clear separation and how well it plays with visual scripting, let's revisit the zombie example. Replace the move visual scripting node with the set nav agent position node. This node uses two ports, the target, which is the NavMesh agent component, and the movement position. This time, let's create a script graph variable node so we can return the target movement position using visual scripting. We can get the target position the same way we did before using the game object find method. And since the target NavMesh agent is the same zombie unit, we don't need to provide a target. The node will infer that we want to use the zombie NavMesh component. As you can see, now we have a clear separation from our nodes logic and how to get the values to operate, since we can pass any NavMesh agent component or position using ports, generating different results with the same node. In Resume, AI Designer provides the necessary tools to create the behaviors of non-player characters in your games like RPG, first-person shooters, strategy. AI Designer can help you bring life to your games.